I guess it's also a good time to sort of start thinking about your project. Hey, um, we will talk about how you connect processing and Max next Monday. Um, but that's not necessary. So it's optional, but it would be more fun if you do want to explore how you can connect both. It would be cool. You can also use jitter and max MSP. I mean, technically max. So max MSP is the audio thing that we talk about. Jitter is the video thing. So you can also explore those. We won't go into that, but I mean, there's also a lot of you know, um, functionality around video processing or gen art in Max. Basically the thing we saw in processing, you can turn it something into the way how Max work. You can also do something like this to generate visual arts in Max. So that's also possible, so feel free to explore those, or figure out if there's some reusable code somewhere else that kind of cool, then you can explore how that works. But good time to start thinking about what you might want to work on or what you might want to dig into. So some of the example project last fall is, people look into some of the cool, music generation models where it's just algorithmic music sequencer in Max, which is pretty cool because there are some people just trying to build some, music um sort of like algorithmic music generator in Max. But you could also explore, like guitar effects or doing like a guitar pedal. You can actually send audio into your Max and then do all the processing, and then you get sort of like an effect that's, just like a DAW you create. You add a plugin. You can also rebuild everything in Max, and you can turn player ones with it. Um, cool. So think about it. I mean, I guess we are not yet into a lot of what Max can do. We sort of like still scratching the surface, but think about what you might be interested in getting into, and you can start exploring some of the stuff. Cool. Just a quick recap. Last class we were basically messing around with the polyphony, which is one of the trickiest thing. So I promise things later in this class is not that tricky. Then no trickier than the polyphony. Polyphony is one of the trickier thing we've seen. Um, but we were talking about this FM idea. So if you are working on the homework, then you likely get a better sense what's going on. Oftentimes, if you play around with it, you will figure out things that you don't necessarily understand, and you get a deeper understanding what's going on. But basically, you have some frequency. That frequency will be the base, and it will be plus tilde. So it will be moving around. That frequency is not static. It will jump around, and that thing is modulated by another cycle here. This cycle is determined by your input frequency times something. So you will be modulating, say, 10% fluctuation, 20% fluctuation, 40, 50% much fluctuation. But that fluctuation is also controlled by an envelope. So this thing is just like, well, I would do 10% fluctuation at the beginning, 9%, 8%, 7%, all the way to 0%. So if you look at this, what it will do is that, well, we grab, say, 440 frequency. Now, if we do 10% here, if this is 0.1, then that one will be, well, we do a 10% jump, but, we just turn it into, say, this is 10%, 5%, all the way to 0%. So this thing is controlling how much fluctuation you are doing with this frequency. So your frequency will change over time. And that's essentially what FMC is doing. So you are not just changing that frequency, but you are changing that frequency based on like another envelope on top of it. And everything here, the things will be, this is the frequency. So this frequency will actually be synthesized into the sound you listen to. So something here will be, 450 hertz, and then go back to 440 hertz, and then 430 hertz. It will jump in around these frequency all the way until at the end, it will be 440 hertz constantly. So things here, frequency will change a little bit, but at the end, it will back to 440 hertz. But you will have these things at the end. This is the envelope that sort of like tune the whole thing together. So the whole things will look like something like this. Pretty bad drawing, but anyway, this is the amplitude modulation. So you could think about, FM things is not just about FM things. This is also sort of like doing amplitude modulation kind of. So you have that envelope that change the amplitude, and these things here are changing the frequency, and you have the carrier frequency going on. And homework is just experiment this and try to make it work with this so that it runs as polyphonic, which is tricky, but the idea is the same. Well, basically, you just turn this into my sound tilde, and that it should work. But you should also explore how these things and the harmonicity, so that you can create some sounds that you might be familiar with, because that's kind of the old school synthesizer are built, basically. And you are buying like a FN synth, and there will be preset program, but basically you are just getting these presets that they figured out those are good sounds or interesting sounds that you might want to use. Cool. Any questions on FN synth? I guess the easiest way is just to mess around with it, and you will get a sense what you are actually controlling, rather than I just explained it to you. So polyphony, very tricky, but I guess one thing that we might also want to know is that ADSR, that there's a built-in object to do ADSR. So the thing that we talk about as this envelope, this is technically not ADSR, because ADSR need node on and node off events. So it will stay at that sustain level all the way until you lift your finger. So technically, this is not ADSR because it will always have the same duration. But ADSR should only release until you lift your finger. But there's an additional thing that you can do. So this velocity 127 we saw last time, when you click it, it will say, something other than 0. But when you lift it, then it will send a node of event. And node of event is basically median velocity of 0. So once you send a 0 here, then this ADSR thing knows that, well, now we want to close or turn off this node. So altogether, you can actually create this poly thing. So this is basically the thing we talk about on Monday. So poly 10-1 basically set up 10 of those, let me 10 of these basically. So this poly 10-1 will assign, whenever you play it, it will assign voice on top of those. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then you play another one, that one will be 1. So you can have 10 polyphony notes, simultaneous notes at the same time once. So it will handle voice assignment, and this polytilde thing will basically create 10 version of this running on the background. And with the voice information, then you can control which one you are sending that. So when you turn on the pitch, you send it to one of the voice, and then you wait until you lift your finger on that particular note, then you will close it. And everything in the between, the swap thing, is just to mess around with the ordering. So what you want to do in the end is that you want to set the voice first, target voice. You want to set it first, and then you send the MIDI node on and node of event message. So swap will turn that, computation ordering, because in Max, everything go from the right to the left. So in this case, if you swap it, then the voice will happen before you get the velocity and pitch. Cool. Question on this? Confident to recreate it without looking at it? No way. I don't think I can do it anyway. Um, yeah, cool. But that's not the goal. Yeah. Oh, good. Yeah. So homework, basically think about turning these things, the cycle ADSR, blah, 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 into FN scenes. And you want to have the preset set up. So for preset, press shift and then click on that. It will save the current setup. So that's another way to think about, load message that we talk about. You want to preset it, but if there's a preset, you can actually have it on to save some of the setup that you have. It will save sort of every thing that you saw on the screen. So, any slider numbers, knobs, everything that's movable or, adjustable, customizable, it will save the states of those. Cool. So today we are jumping into another topic, which is called filters. So what is filters? So filters is basically an idea that you are just using, well, it's technically something that's from the physical era where you can design a physical filter to modulate a signal. But let's take a look. Turn this on. No sound, of course. Cool. So this is the sound that did I do anything wrong? Cool. This is actually what you want to hear. So this is the original sound. And so this low res is basically a low pass filter. So if I set this to a very high number, then you sort of get, what is this? I kind of forgot. I think it's 0.5, right? Yeah, that's the resonance control. Let's set it to 0.5. So this is the original sound, kind of. So low pass filter is that we can see it. If we set it to 1000, then you can see in the output part that everything sort of being, reduced. If I set it here, then there's that high frequency component. So this is basically just the bass drum or the lower components of that. So this is basically the low res, so low pass filter basically. So filter is just thinking about the spectrum, and we are so low pass filter. Ideally, what we want is like this, and this is like that or not, or not. So you want to keep everything below this threshold frequency. So as you see, like, ideally what you want is that everything be on this but this is technically actually impossible to achieve. So usually what you get is something look like this that will go straight here and then go up and down. Oops. And go something like this. So that's the physical sort of like limitation of filter that you can design in real time, that run in real time. So there's no way you can get rid of this. You can actually create this perfect things. So this resonance is actually just controlling how much things here that you will get. So you can actually create different version of that. If you want it to be less, that's pick here, then you will have to do it longer. So there's a trade-off that you can not avoid. So we can see it actually here. So that's the physical thing. Hey, I'm seen here, and you can actually see it here. That's on the circle because of the algorithm. But if you make the things larger, you see that it now becomes that's there's a peak. But if you become lower, then it actually becomes flattened one, and there's more detail that it doesn't. So the sharper you want when you are controlling the resonance, the sharper you want the spike, the bigger that you will get. So it's a fundamental things that we cannot avoid. But anyway, low pass filter by design, what we are trying to do is to just keep the lower frequency things. And even though it sounds a little bit unfamiliar, but actually lots of electronic music nowadays, when you are between the sections, you actually use this effect to sort of like tune it so that you hear that frequency just coming out, and then you create that climax so that you jump to another section. So that's a common way to do it, but just that in Max, everything is from scratch. So low pass filter is like as it is in this case. Well, if you want to know what these filters are designed, this is DSP, digital signal processing. So there's a tons of mathematical theorem behind how you can actually create these kind of models so that you can run, like a signal thing. So the complexity here is that your input is like an audio, and what you want is like this audio processing in real time that will actually have the effects of like getting rid of the lower frequency part. And that's the reason why things cannot be perfect. There's no way, theoretically, no way to create this very sharp frequency cutoff. If you want to do it real time, audio waveform to waveform processing. So another thing here, this is the resom object, so we can listen to it. Now there's more things, and if you check on the inlet, input gain, center frequency, and Q, that's the resonance, so we can see it. Let's check out the frequency. Cool. So what you're getting here is sort of like you are keeping only the middle part. So this is another kind of, I think I do have those. No, I don't have those. But anyway, this is sort of like creating sort of like a bandpass filter. So what you want here is now, I want to keep this fretzo. I want to keep the sound between that. So what you want to get is something like this, that you just want to keep frequency around that center frequency. So you can see here that you only keep the frequency around that. So this is called, I don't really know what they are called, but resom here is the one that you can do it with this way. So the same idea, this resonant things will determine how big this spike is. The sharper you want, there will be additional spike around, and you can also create different versions of that. Cool. So anyway, this is sort of like similar to a bandpass filter where you can just grab a certain frequency band. Even though this is not the most common one to use. So there's a bunch of other filter that we will just look into. So this SVF thing is basically having all these different kinds of filter all at once. So you have low pass output. So think about low pass and high pass filter is basically doing the same thing. So, this is high pass, this is low pass filter. This is what you want. And for a high pass filter is basically the opposite, that you want to have everything here. You want only the high frequency, and low pass filter is you want only the low frequency. So you can actually get all of those in just one single function where you set you set the frequency, you set the resonance. Let me So this is the low frequency one. So the first one is the frequency. If you look at this, low pass output. Sorry about that. So low pass, where it is, low pass output, high pass output, band pass output, and the last one is the notch. So low pass and high pass, easy here. And the band pass is something like this, where you just want that frequency. And notch is the one that doing the opposite, that you want to remove that particular frequency. So you can actually just use this SVF thing, and altogether you can get out of those sounds. So you can look at it. This is low pass. So you see that all of the high frequency one are done. But you can also do high pass. So now the lower frequency stuff are done. So if you do 0 and everything is still preserved, now remove the low frequency. So for this case, you only got frequency larger than 16 kHz, and that's why it sounds very sharp. You have bandpass filter, which is basically just grabbing the frequency around that. You see that this is just grabbing this part, and this is just grabbing this part, and grabbing the middle part, grabbing the highest part, grabbing the high frequency part. And you also have notch. So that here, somewhere here. So this thing is a little bit. So you can see that dip. When you move around, you can see that dip just moving up, moving down. Dip. That's moving around. But anyway, these are the filters that you can use, SVF. So actually, that will lead us to something interesting that we can actually create a drum machine that we will see next Wednesday. What are those? Yeah, but basically you can get all of that's all at once. You can compare them. So this is low pass, high pass, this way. So all of those for different filters. Cool. So there's even more of that, where you can also use these things. Well, things are getting more trickier and trickier. So there's actually much more than that. There's like low pass, high pass, band pass, and band stop, peak notch, low shelf, high shelf, resonant, all pass filter. These are actually all kinds of different filters that you can use, and you can create different things. So I would just show you how this works. This thing is called, filter graph, tilde, where, you just do an filter graph tilde, then you will get this kind of thing. And these things actually take low pass, high pass, blah, 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 all these inputs. You can also create this U value to control it. But basically, once you do low pass, you will see that. High pass, it would turn it into high pass. Band pass, band stop. So this is a notch. Peak notch, you have to do it this way. Low shelf is like you have this, like, say -3 dB, and then turn it back. So this is not different from low pass. So low pass, high pass versus low shelf. So high pass is like everything here is like nothing, 0, negative, infinite dB, and you turn it into this thing. Let me grab it back to 0. So this is a typical high pass look like. Low shelf is that, well, let me grab it. So again, high pass, low shelf, the difference is clear that, low shelf is that you reduce these level for lower frequency, but you don't want to cut it off. High shelf, the opposite. Resonant is the thing that we talk about, sort of like bandpass, but it's not essentially bandpass. It's just a different types of filter design. O-pass, it's the one thing that's very tricky. So O-pass is actually doing phase modulation. So it will change the phase of your inputs, but every frequency will pass. So you might wonder why O-pass. I always doubt that. But O-pass has its own unique way of doing stuff. You can actually change the phase, and there are some applications of that, though I'm not quite sure what those are. But anyway, O-pass is theoretical possible things that you can do with this filter design. So low pass, high pass, band pass, these are clear. Band stop is a notch where you just remove this part of that. So say you record something and there's like a, because of your room, there is like a standing wave that just keep popping up, then notch would be helpful to get rid of those. Low shelf, high shelf is just similar to high pass and low pass, but you still keep some level. And resonant is similar to bandpass. O-pass is like just changing the phase. So you can actually do all sort of things using this filter graph. But filter graph is nice because, you can actually just directly play around with it. So this is things. Filter graph, not filter graph, spectral scope. To show this, what you want to do is that this is actually the same spectral scope. So this is the one that you are familiar with. But if you turn it into sonogram, then you will get something like this. But this is just keeping that spectrogram and playing it. Got it? So sort of like the SDFP idea. So this is like helpful when you are playing around. Because you can see that now every frequency is gone, and then let's do it later. So let's add back the high frequency part. And you can see that now the high frequency part are back. You can do high pass, the same idea. That only the high frequency will stay. So all the low frequency are gone, and you can put it back. But more interesting is band pass, where you can just move around and focus on different parts of the frequency. Well, so that's not so fun so far. What's interesting is that you can actually compose of these filters to create EQ, basically, equalizer. So what you can do, where I can see it. My bad. Let me see what's going on. I doubt this should be one. I'm sorry about that. I'm not quite sure what's going on here. Let's see. What we can do is do on top of that. I'm not quite sure what I'm trying to do here. I think I forgot what this number should be. Let me see. Let me turn the volume lower. Pray for Zoom folks like that. Yeah, life will be miserable on Zoom. Cool. What we are trying to do here, let me set this up, and I hope. Yeah, we saw it. Okay. It's not. Is that correct? I don't know what's going on. It shouldn't be like that. I doubt I did it right. Maybe because this number is too high, I guess. Let's do 0.5. Let me try it again. Sorry, Zoom folks. Okay, much better. Yeah, I set the rest of the things too high. So 0.3. So what you're seeing here is that, you can actually turn this, you can actually modulate the low pass frequency. So this is essentially some of the, electronic music that you just suppress all the high frequency components and then you add it back. So if this happened much faster, then that's essentially, some of those, you have a knob that you just do the high pass filter and low pass filter to create those effects. That's what I want to try to show, but I forgot what exactly number I'm using here. What you just hear, that very sharp sounds, is because I set this resonant number too high. So if the resonant number is too high, then basically you will create a huge, jump here that just look like this. And so for these, it's actually something like plus 6 dB, or, it's just like exploding. That's why you hear that very sharp sound. But usually, something between 0 to 1, this shouldn't be that tricky. At most, it will be 3 dB only. Cool. I guess I should also remove this so that it won't make any sounds anymore. Well, I don't, because I have the play button here. Cool. So this is like EQ, equalizer. So actually you can pack all these three things together to create sort of like an equalizer here. So what you're seeing here is, this is like a low pass filter where you can move things around. This is like, this is not low pass. This is not a, what's that? Pick notch, yeah. So you have a pick notch, say you want to boost, I don't know. This is like 60. Say you want to boost 3000 hertz. And this is high pass. This is low pass. Okay. Let's reset those. And this is high pass. I think the default are just weird. Okay, cool. That's
with a party at, I need some of that primitive action. Give me that bass, give me that kick drum. Keep me loose like Valium. If you with a party at, I need some of that primitive action. Give me that bass, give me that kick drum. Keep me loose like Valium. If you with a party at, I need some of that primitive action. Give me that bass, give me that kick drum. Keep me loose like Valium. If you with a party at, I need
reduce
some
that frequency range, but also low pass filter. But this is essentially, you can create your equalizer on the fly. And everything combined together will be the things. So what's going on here is that, you grab these controls and you will get something out. So what you're seeing here is that you are just packing all these outputs together. This is what the output look like. So every five numbers correspond to the first one. So these five numbers determine the thing, and these five numbers determine the things, and these five numbers determine the things. And these filter can actually go on top of one another. So you can actually combine these three numbers and show it all together, like these three adding on top of one another. You can compose them basically into an equalizer. So this is sort of like, think about it like a 3-band equalizer, and you can of course create more bands. But one thing about this is that you can also just, this is like composing different things all together, but technically you could also just do it with one filter graph that if you do the output as cascade rather than previously, I forgot what that is, SVF, is that? The last thing, oh, the biquad. So, now if you replace biquad with cascade, then now you can actually do more than that. Well, I haven't used this for a while. I believe that you can add one with Shift or Alt, but somehow I don't know how to get rid of that. Let me see how I can add one to that. I think it's here. So active filters, if you do 5, then you can get one of those, one more of those. I think there's some shortcut that you can actually add one more, but I forgot how to get it. But anyway, this is sort of like combine everything we see previously. So everything in the middle are like big notch by default, and this one will be high pass, and the last one will be low pass. So if you click on those, you can actually decide what those are. Kind of forgot how to move them around. But anyway, this is another way that you can actually compose an equalizer for your sound. Do you want to play with this? I guess this is one thing that we can play around with. Cool. So you can get these sounds from the example sounds here. One thing you want to do is to set the duration filter so that you get those longer duration ones. Otherwise, these short duration stuff are one-shot sounds that doesn't really help. So if you set the filter as long, there's something like um play with it. Cool. This thing is called filter graph. I believe there's a shortcut to get this. Maybe I put it here. Shortcut. What's the shortcut? Well, I don't know. But anyway, you can change it in the inspect by changing here. Well, I guess that's it. Oh, good. Well, I guess why are we doing this? That's actually what we are going to look into. So I can just show you what we are trying to do next. So this thing is called subtractive sinks, basically. So the idea is that we can actually use this idea of filter to generate some drum sounds. So think about what's going on here. It's that you have 50 cycle. Basically, that's a 50 hertz sinusoid function. So you have 50, that's like a sine wave that's like this. And then you basically just, get an envelope of that. And it just sounds like a bass drum, right? What if you want to do a hi-hat? So hi-hat is a little bit tricky because hi-hat span across the whole spectrum. So what you can do is that you can actually grab a pin noise. So that's get rid of these. Let's just listen to what. So what you can do is that grab this pin noise and now you apply some filter on top of that. So what you can do here is that let me do it. So what you are seeing here is that you have a hi-hat, like a high-pass filter. If I didn't do anything, that will be the full pink noise. But here is the envelope. So it go from 0 to 1, so the very sharp attack, and then go back to 0. That's the amplitude envelope. But now if you add, it's gone. I couldn't make it back. Let's just do it this way. Add the more. Well, how can I get it back? Oh, okay, it's back. Cool. So, now we can move it around. Now it sounds more like a hi-hat. You can also use bandpass to do something like that. So this was some more like a somewhere here. I think it sounds like a snare here, I think. It doesn't sound like a snare, but you get the idea. So actually some of the early days drum machines, they are actually using this idea. So this is called subtractive synths, is that you grab some, noise as input. Now you do the filter and then you apply this envelope. Now you can create those, good old, 808 sounds, kind of drum sounds. So that's basically the idea. So you can essentially just create your drum machine, something like that. So let's just listen to these. If I do, I don't know what this is, likely like a cymbal sound that I'm trying to do. I'm just trying to remember what's going on here. And the hi-hat sound, you just listen to it. And the kick, so the difference between the kick is that these are pink noise being filtered. So it's more full spectrum, but you are doing filtering. But for kick, it's like a simple, just like a sine wave. But you can also think about other ways to do the kick drum. But in this case, well, just a single sine wave and you have an envelope. It sort of just sounds good enough as a kick drum. And for snare drum, then you do the same idea, pink noise, but you find somewhere in the middle that sounds nice. Then it sounds something like this. Good enough as a snare drum. So what you can do is that actually you can create some drum pattern here. Say just a very boring rock or something like this. All right. I mean, actually, the kick drum sounds too low. Anyway, I'm just showing you some of the idea of why my keyboard is not working. Oh, cool. Anyway, get the idea. So the hi-hat is like this is like whole so this is sort of like additive since even though we just have only one at zero, but if you can think about you add more of that, then this is additive things. Then this is like subtractive things. Subtractive things is that you grab ping noise. So ping noise is basically frequency. This is frequency, and you have the so white noise is something like this. This is white noise. This is pink noise. So the difference between pink noise and white noise is that the higher the frequency, because our ear doesn't like very high frequency things. And in general, in real life, pink noise is more similar to what we listen to in the real life. There's more frequency, lower frequency than higher frequency in general in natural sounds. So pink noise is more, similar to what we have in real life, that the amplitude will be lower for higher frequency. And white noise everything, the TV noise that is like something like white noise that has the full spectrum across all frequency, but these sound too sharp most of the case. So you have the pink noise. Now you apply you apply. So say you have this pink noise. Now what's going on here is that you apply a bandpass, or in this case, a high pass filter. So think about a high pass filter going on here. Then what you get essentially is just this part. I am sort of breaking this red by pen marker. Anyway, so what you get is just this part of frequency. You can actually sew it by using the spectroscope here to see what you're actually generating. Cool. Let's take a look what those are. So the hi-hat. So you see that it's actually getting a bunch of high frequency, and that's essentially what hi-hat is. Hi-hat is like, if you look at the spectrogram, it's usually just like an impulse, like a very vertical things showing up. For bass, it's it's different. Cool. So, bass is just like a very sharp that. I mean, of course, that's not the only way you can do the kick drum. Cool. So just showing you some example. And I guess we can just go ahead and finish this module. This is just showing you, some way that you can play like a sequencer, basically. So this sequencer is just doing the same idea. So this thing is called metric control. So metric control, you can think about this is just like I don't know. Say you have a drum pattern, something like this. So bass, hi-hat, and snare. So basically this, maybe let's put it this way. So don't stats, basically. So what you can do here is that if you have 0, if you click this, then you get the first one. So you get the first row. And now you have 1, then you get it, then you get the second one. So you get the things here. So basically get column is like we get 0 and get 1, get column 2, get column 3, get column 4, get column 5, get column 6, get column 7. So what you want to do, this scene, you can see the outputs here at the right, 0, 1, 0, 0. That's basically the second column. So you can imagine what you can do is that now, if we have a metronome that keep sending 1, 2, 3, 4, 5, we have a counter, we have a metronome, then we can basically create a sequencers that just trigger this get column and go from 0, 1, 2, 3, 4, 5, 6, and go back to 0. So that's sort of the idea of what we are trying to do here with a MIDI drum, like a drum machine. So what you can do here is that, this is the Metro 200. So every 200 millisecond, you will send a fan message. I guess the easy way is to show it here. So now I turn it on, then it will have a metronome that just every 200 millisecond, there will be a band. And these things will trigger and put it into this counter 7. So this counter 7 meaning that it will go from 0 to 7. So 0, 1, 2, 3, 4, 5, 6, 7, and then going back to 0, as you can see here. So 0 to 7 and go back to 0. So that's essentially what we want. So once you have that, so again, this $1 will basically grab whatever coming in, put it here. So this thing will be get column 1. And the next time, say you have a 3, then 3 will be put here, get column 3. So that's essentially what you can get here. So let's do something like this, the good old don't stats. Then you get something like this. Kind of hard to see what's going on. Let's turn it into 500 and see. Hopefully it's easier to see. So you see the things basically turn into the things. And so that you can basically turn your homework, the MIDI drum things into something that you can control. So what you can do is just grab everything you have and turn it into a make note so that you are playing the drum sound. So I can show you what you can do here. It's kind of not. So that's essentially, what you see. So likely, what these are. Bass drum, 35, 38, snare, hi-hat. This is likely cymbal. Yeah. So, if we just do something like this. Oh, no, that's open hi-hat. So, it's just like a sequencer that you can do. So, basically, you can do metro and you do the counter so that it go from 0 to 7 and go back to 0. And this get column thing will trigger this metric control to output whatever that have. Then you unpack them. And the select one will basically just see whether there's a 1 coming out. If there's a 1 coming out, then you trigger this button that will trigger this message. Then this message will be sent to make note. So to set that particular MIDI pitch, and because you are using 10 as the channel, so this will be drum sounds. Cool. So this is like easy things that you can do with MIDI drum. And what you just saw, just with the filter things and also bass, is that you can, beyond MIDI drum machine, you can actually create sounds that you like. So you can use subtractive synths, you can use additive synths, you can even think about FN things. Sometimes FN synths, if you set it properly, you will also hear sound of those drum sounds. Cool. But anyway, you can actually also create a kind of longer. Anyway, shall we play around with this thing? I think one thing we could try is this, basically. What should we try? I guess we can try this. So play around with this matrix control, basically. Cool. But we move a lot faster than I thought. But that's good. Then we can get into processing earlier so that you can think about what you can do in projects. Yeah. Cool. This thing is called metric control. So this thing is also work with the preset. So you can also use preset to sort of like store those patterns that you're interested in. Cool. Know that you want the right-hand side because this thing is the row column value as list. The thing is another thing, that's the cell value. So that's not what we want. Yeah, try to build it yourself so that you can see that's max. It's like, whenever you just play some those, max patch, you don't really figure out what's going on. So what you're seeing in the middle is that unpack these things and you see that this is a 0, 0, 0, 0. So it will turn these number into 4 different outputs. And whenever there's a 1, then it will send a bad message here. So this is just like a filter, basically. So this contrast thing doesn't necessarily need to work with Metro. So basically it would just take a bang, whatever time you want, and you would just keep counting it. And metronome is just a way that you create a steady bang message. It's basically just a way to show the bang message. If you do want to get those sounds, you know how to do it in homeworks and also last week polyphonic. But basically once you at this point, after these, there's just like your MIDI synthesizer. But now you have these triggers. Now the idea would be this trigger could trigger the bass drum, trigger a certain sound. And that's essentially what's going on in this example. So here is actually doing the same thing. So once you unpack 0, 0, 0, 0, select 1. What's going on here is that it will send this band message to here so that you have this receive my sound. So it will trigger these things and just compute the whole thing. So this 4 things is basically sending band message to each of these synthesizers. So this is like the cymbal synthesizer, this is snare drum synthesizer, kick drum synthesizer, hi-hat synthesizer, and you are sending the same idea. So it's just the same idea, right? where's yeah, so these two are essentially the same. If you look at the until, so from here to select one is essentially here to select one. Now you get 4-band message output, and these 4-band message will be triggering each of the synthesizer in this case. But here we are thinking about, just MIDI synthesizer, so we don't necessarily need to worry about how you are going to synthesize each of the sounds. But in this case, then we are synthesizing the sounds using Max MSP rather than, the built-in MIDI drum sound. Cool. So yeah, this is sequencer drum machine, kind of. But of course, it would be more fun if you just this is like program drum machine sequencer. But you can also, of course, just do it on your keyboard. What we can do in addition to what we just saw is we can actually also use a sample-based drum machine where basically we just play a certain sound. I would just show you, but oh, okay, let's reset. So here, what we are doing is grabbing some example files that we have. We already have these files. We can listen to it here. So this is like the hi-hat waveform. Very slow. That's it. Kick drum. Very slow. So yeah, you hear that. That's the kick drum. So these are like single shot, very short recording. But we can also do it. How you want to do it is using this buffer tilde thing. So this buffer tilde things will sort of like store the waveform that you have into something you can call. But that's the idea. So buffer hi-hat. So this will be, think about this like you are doing a variable. So you are creating hi-hat equal to sort of like load waveform of that particular waveform, kid, blah, 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 dot WAV. So the things basically just do something like this, that, you will store this waveform in the same folder and store it into hi-hat. So now what you can do is here you can do play tilde hi-hat. Then you can two, meaning that you have like two outputs channels. So it's stereo. So that's how you can do it. So in this case, then you can also do the things. So these are basically using the sounds that you have stored. So one thing about that is that, we can do buffer tilde to get some of these waveforms. So store these waveform, load it into, and put it into this loop. So now we are creating this variable loop equal to the sounds that we have. So one thing you can do with this play tilde things, play tilde loop 2 basically means that now we have this file. This is like a player that you can work with. Stop, start, stop, pause, resume should be very straightforward what we mean. But this 2 meaning that the outputs will be stereo. If we didn't do this, say if we do 1, then you see that the output only have 1 mono output. So this one is the another thing. That's not the outputs that we want. So if this sounds is stereo, then we do 2, then we see, left and right. So you can also work with this, in other ways. Start, stop, then you will just count, start, pause, and then back, start again. Or, pause and resume. So basically, this is like a player kind of things that you can play with. But in the case of this drum machine case, then we just only want to use start to play all these sounds. So these 4 sounds are already loaded into, your hi-hat, your kick, your snare, your rim. Then you basically get all these sounds. So this is the rim. When you click on the snare, the rim of the snare, hi-hat, snare, and kick. I guess that's also why it doesn't sound right. Let me try this. Doesn't sound right. But anyway, this is another way that you can do. And of course, that the one thing that we talk about here, where you can actually play with these. We can try these next class. Actually, next class we will looking into processing, but after that we can take a look on these. But this is fun because you can basically look into what kind of hi-hat sounds you are interested in. What would you like? You can make it, longer, then it no longer sounds like hi-hat. Hi-hat is very short and impulsive. Kick drum is usually longer, but you can also make it shorter. Cool. Questions? Oh, good. Yeah. We will have homework due. Do we have homework due? Next Monday. So what? Oh, not yet? Okay, cool. I'll set it up. I think I forgot to set it the right date. Cool. Polyphonic FM scenes, meaning that you've done it? You've finished it? Cool. Have you completed? Not yet? Okay. Anyway, think about it. Yeah, shouldn't be too tricky, but but it's not trivial either way. Cool. We're getting close. And we will look at networking and open sound control so that you can send message from processing to Max. And I'm thinking about, I haven't designed homework 7 yet, but likely we will play some sounds back and forth from processing and Max. Then that will give you some idea for the final project, hopefully. But again, connecting to processing is optional. You can just do Max MSV, whatever you like. Cool. See you on Monday then.